Hey there friends, in this video I'm going to show you how to use linear approximation to estimate the value of 1 divided by the square root of 65. When you see these buzzwords, linear approximation, or when you are asked in the prompt to approximate the estimated value of some number, this is the formula that should come into your head. Let's break down the elements of this formula. First, what is our x and what is our f of x? Your x and your f of x are always given to you in the prompt in the form of whatever number they're asking you to estimate. This is made up of our x, which is the 65. We're plugging 65x into 1 divided by the square root. So we've written that here, x equals 65. The function that we're doing to that 65 is 1 over the square root of x. Now you may be wondering, I'm seeing a up here. F of a, f prime of a, not f of x. What's a? A is a number that we pick that is close to x, that is much easier to plug into this formula. Here we're going to set our a equal to 64. Why set a equal to 64? Like I just said, because 64 is very close to 65. And taking the square root of 64 is going to be a lot easier than taking the square root of 65. We'll get a whole number when we take the square root of 64. So speaking of, let's go ahead and plug that a into our function to get f of a. Plugging in a equals 64 into our f of x gives us an f of a of 1 over 8. So far we've just been doing algebra in this problem. This is a calculus problem right here when we take the derivative of our f. This may be easier to do when we turn this f of x into a variable with an exponent. Our f is really x to the negative 1/2, so let's take the derivative of that. We're starting with the negative 1/2 as our exponent of x. When we subtract 1, we're left with negative 3/2 as our exponent of x, which means it's going to go in the denominator to make that exponent from negative to positive. Our derivative shakes out to be negative 1 over 2 times x to the 3/2, or negative 1 over 2 times the square root of x cubed. Okay, but up here we have f prime of a. Let's plug in a into our derivative. When we plug in 64 into our derivative, this is what we get, negative 1 over 2 times the square root of 64 cubed. If we do that work here off to the side, that gets us 512. So our derivative at a is going to work out to be negative 1 over 1024. Now we have all the elements that we need to plug into our linear approximation formula and solve. First up, we have our f of a, which we calculated to be 1 over 8. That's going to be plus our f prime of a, which we calculated to be negative 1 over 1024. Next up, we have our x, which is 65, minus a, which we set equal to 64. So this is our linear approximation formula setup, doing the calculations kind of ahead of time so this looks a little bit more clean. Let's go ahead and do the arithmetic on this to solve. Here, the 65 minus 64 is just going to be 1 times this negative value, so really we're subtracting 1 over 1024. Let's give ourselves some common denominators here. Linear approximation problems are supposed to be problems you can do without a calculator. If you're looking at 8 and 1024 and thinking you expect me to figure that out without a calculator, let's just stop a second and think about 1024 is really the same thing as 1000 plus 24. How many times does 8 go into each of these? Well, we know 8 goes into 24 3 times. 1000, I don't know 8 right away, but I know that 1000 is divisible by 4, that's 250, and half of 250 is 125. So that's how many times 8 goes into 1000. Add those together, you get 128. So let's multiply this top and bottom by 128 for our common denominator of 1024. 128 minus 1 is going to be our final answer. 127 over 1024 is our estimated value for 1 divided by the square root of 65 using the linear approximation formula. If your professor or tester is looking for a decimal, your decimal answer is going to be this, 0.1240, so on. You can check this answer by typing in 1 divided by the root of 65 in your calculator, which is going to give you a very, very close number. These two numbers are right on top of each other. We're off by maybe 100,000th or so. So you can be confident that this is a very accurate estimation. A couple points to remember. take your time on the derivative. Don't be a hero. Write out your work. Make sure you're doing the right thing. I've messed up this derivative. It's easy to make a mistake. Take your time and write it out. Double check your work. Same thing down here. I've written 218. I've mixed up the 1 and the 2. Take your time when you're finding the least common denominator, because you don't want to set this do all of this right and then make a silly mistake down here. So just take your time. You'll save time in the end when you get the right answer. If you found this video helpful, if you're looking for other linear approximation example video tutorials, practice problems, I've linked my other linear approximation tutorials here for you to go ahead and check out. I hope I see you in the next video.